All right, ladies and gentlemen, this is going to be our next video on acids, bases, and pH. So let's get started on this next video. So I want to go through and briefly review the water molecule. So we've looked at the water molecule a couple times, but I still want to go through and review it. So over here we have two hydrogens on the bottom of our water molecule, and then on the top we have our oxygen. Remember, it's 8 protons, 8 neutrons, and then we're sharing the electrons in covalent bonding amongst the hydrogens and the oxygen here. Now, the important thing to remember is, as we go through this, we have to remember water is a polar molecule, and this has to do with the sharing of the electrons. So, at the bottom, where the hydrogens are, we're going to have a partial positive charge, and then at the top of the molecule, over the oxygen, we have a partial negative charge. And this is going to affect the polarity, and this is going to affect how the water molecules go through and bond. Now, what you guys see at the bottom here. So the important thing to understand here is water is not always going to exist just as H2O molecules in a water system. So if we look at this animation here, we can see 3 water molecules, and they're all held together by hydrogen bonds here. Now, hydrogen bonds are really, really strong intermolecular forces. And sometimes what's going to end up happening is one of the molecules is actually going to pull off or release hydrogen atoms, and what's going to happen is we're going to have the formation of hydronium, and then we're also going to have the formation of hydroxide ions. Now, water's a little bit weird. Sometimes what's going to happen is the hydrogen bonds are so great that they actually pluck a hydrogen off one of the other water molecules. So one of the water molecules loses a hydrogen and the other one gains one. And we call these hydroxide and hydronium ions. So OH, because there's one oxygen and one hydrogen, and H3O, 3 hydrogens and 1 oxygen. So if we look at the net chemical reaction here, well, we start off with 2 water molecules. And those water molecules are going to go through and potentially exchange hydrogens dependent upon the polar forces that they interact with, or the hydrogen forces that occur. So we get a hydronium ion. We also get a hydroxide ion. And they're ions because we've gone through and given away protons and electrons, because we've gone through and given away a hydrogen or taken a hydrogen. So a hydronium ion has an overall net positive charge, whereas a hydroxide ion has an overall net negative charge. Now, if we look at this written out, we can see H2O going through and turning into H plus or OH minus. This is another way of writing out the chemical reaction that I've shown you below. So let's go through and make sure we review quickly what's occurring here. So first off, water molecules sometimes split apart to form ions. Remember, this is because of the force of the hydrogen bonds that exist in the water column. So H2O can split into H plus and OH minus in the water column. Now, pure water is neutral, and it has an equal number of positive and negative ions. So we have an equal number of hydronium and an equal number of hydroxide. So if we were looking at a glass of water, it would have water molecules. It would also have an even amount of hydronium ions and an even amount of hydroxide ions if it was purely neutral. Now, the other thing we have to keep in mind is pH is dependent upon the quantity of these hydronium and hydroxide ions in the water. So let's go through and try to understand what acids and bases are. So if we go through and we increase the number of H plus or hydronium ions in concentration, we are going through and adding an acid. If we increase the number of OH ions or hydroxide ions in the concentration or in the solution, we're getting a basic solution. So if I go through and add in hydronium ions, if I'm going through and creating an acid, what I'm going through and doing is creating an unequal amount of H plus to OH minus, and the solution is acidic. Now, if I go through and add in OH ions, well, now what I'm doing is creating an uneven amount of hydroxide ions compared to our hydronium ions, and now the solution is basic. So let's go through and try to understand, if I add hydrochloric acid to a solution, what is going through and happening in the solution. So HCl is going to split up into its counterparts, and what's going to end up happening is I'm getting an acidic solution because my H and my Cl, or my hydrogen and my chlorine, are going to separate in the solution. As a result, I get chlorine ions in the solution, and I also get hydrogen ions in the solution. Now, some of the hydrogen ions are going to interact with my hydroxide ions, and that's going to neutralize and create water, but I'm also adding extra free hydrogen ions to go through and create an upset in the balance of the hydroxide to hydronium ions. So now because of that, because I have more hydronium ions, in this case, my solution is acidic. So if we're thinking about this, we can measure this quantitatively using the pH scale. The pH scale is just measuring how many H plus or OH minus ions are in solution and the ratio between the two of them. So if we're going through and looking at this, what we can see is pH is the power of hydrogen. So how many hydrogen ions there are in solution. So pH, we're measuring the amount of H plus ions in solution. If we were measuring pOH, we'd be measuring the amount of OH minus ions in solution. So this is going to measure the relative concentration of H plus ions. So if we are at the end of the scale, the middle of the scale, and the other end of the scale, what we're going to see are a couple of different things. So if I'm towards the left of the scale, it means that there are more H plus ions in solution than there are OH minus ions. So we consider these acidic solutions. Now, if I am from the middle to the end, the other end of the scale, in this case, there are more OH minus ions. In this case, the solution is basic. We can see something like a lemon or Coca-Cola is going to be acidic. There's more H plus ions in solution compared to the OH minus ions. And something like a bee stinger or toothpaste is going to have more OH minus ions than there are H plus ions. So therefore, it's a basic solution. So let's go through and try to just write down acids and bases and characteristics of both of these. So an acid. In this case, an acid is going to be a little bit different than a base. So in an acidic solution, we have more H plus ions than OH minus ions in the solution. The pH numerically is going to be less than 7, and then the lower the number, the stronger the acid. So an example is hydrochloric acid, which is a strong acid that's in our stomach to go through and digest food. This is going to be at a numerical value or a pH value of about maybe 1 to 2 to 3, and that's going to be more acidic than a solution or an acid that might be 5 to 6, and then 7 would be neutral. Now, bases are going to be different. They're going to produce more OH minus ions in the solution than H plus ions in solution. So a pH that's greater than 7 is going to be considered basic. The higher the number, the stronger the base. So 14 is greater than 13, so something that has a pH of 14 is more basic than something that has a pH of 13 or 12. Now, an example of this is sodium hydroxide, and this is an alkaline solution that's used to make soap. Now, sodium hydroxide is going to dissociate. The hydroxide ions will go through, exist as negative ions in the solution, and then therefore upset the balance of H plus ions to OH minus ions, and therefore creating a basic solution. So if we're thinking about this, we have a variety of different acids here. So an acid is a compound that releases H plus ions into the solution. So H plus is the hydrogen ion, or H3O plus is another way of going through and representing this. Now, we represent it as H plus. H plus and H3O plus mean the same thing. So we're talking about the same hydronium ion. H plus is kind of the shorthand way of going through and writing this. Now, if the H plus ions in solution are greater than the OH minus ions, then the solution is acidic. So let's go through and look at hydrochloric acid. Hydrochloric acid is going to dissociate into H plus and Cl minus ions. And this is going to be extremely useful for the human body because it allows us to go through and use an acid in our stomach to digest food. Now, bases are going to be different. So bases are composed of compounds that are going to go through and release OH minus ions into the solution. So OH is our hydroxide ion. Now, if the OH minus ions are greater than the H plus ions in the solution, then it is basic. We can also call this alkaline. The last thing here is if we have sodium hydroxide, what it's doing is dissociating into sodium and the hydroxide ion. And an example of this would be like baking soda. baking soda is considered basic, and that's why it has the cleaning powers that it does if you use it on clothes. So let's go through and try to interpret the pH scale. Now, here's the pH scale again through this image. And what we can see here is the pH scale is going to increase via logarithmic functions here. So it's a log scale, so it's going to increase by powers of 10. What does that actually mean? So a pH of 5 is 10 times more concentrated than a pH of 6. So let's go through and look at this numerically. So if I had a pH of 0, the numerical value associated with it would be 1. So as I go up to a pH of 1, what I'm going to do according to my logarithmic scale is do 1 divided by 10. So the numerical value associated with it would be 0.1. Now if I go down to, let's say, a pH of 2, well, now I'm going to take 0.1 and divide that by 10. So I can see that the numerical value associated with a pH of 2 would be 0.01. So as you go through, going down and up the scale, you can see it's a logarithmic function. So in this case, a pH of 1 is 10 times more concentrated than a pH of 2. A pH of 2 is 10 times more concentrated than a pH of 3, etc., etc. It is not a linear function, it is a logarithmic scale. Now, we can classify acids and bases dependent upon what they are. Strong acids have a pH value between 0 to 3. If we're looking at weak acids, they're somewhere between 3 and 7. Strong bases have a pH between 11 to 14, and weak bases have a pH between 7 to 11. Technically, a neutral pH is at 7. That is an equal number of H+ ions and OH- ions in solution. So, did you guys learn? Well, did you learn a couple of things? Did you learn ions in acidic and basic solutions? Did you guys learn about how acids and bases form? Did you guys learn about what acids and bases are? And then did you guys learn about the pH scale? This will be the end of the video. I will see you guys in class tomorrow.